My name is Flash Isaac, and I'm a teacher from the future. When I was much younger, I saw thousands and thousands of people fail Jamb and unable to gain admission. This made me travel in time. Now I am back with the Flashlearners Jamb app and a series on YouTube tagged 120 Days to Jamb. My mission is to help you blast Jamb and as well get justice for everyone who Jamb has served breakfast. This is episode number 81 of the 120 Days to Jamb Chemistry with Flash Isaac. In this episode, I shall be introducing you to something very, very important. Organic compounds can be grouped or classified into two. They are the hydrocarbons and the non-hydrocarbons. So far in the series, you will notice that most of the compounds we've treated, they basically contain carbon and hydrogen only. Some of them single bond, some double bond, some triple bond, but they are carbon and hydrogen only. Carbon linking to hydrogen without any other element. All these compounds containing just carbon and hydrogen alone are referred to as hydrocarbons. And the ones that contain other functional group, other elements like alkanols, aldehyde, alkanones, carboxylic acid, ether, esters, and so on, that contains other elements apart from carbon and hydrogen, they are referred to as non-hydrocarbons. So organic compounds are either hydrocarbons or non-hydrocarbons. Hydrocarbons are divided into two. They are the aliphatic hydrocarbons and the aromatic hydrocarbons. Please pay attention because under hydrocarbons, I will just give you the hydrocarbons and their properties, uses, and preparation. I won't expand this again. Organic compounds can be hydrocarbon or non-hydrocarbon. Under hydrocarbons, they are divided into two: aliphatic and aromatic. Aliphatic hydrocarbons are hydrocarbons that contain straight chain or branch chain or cyclic form. All the compounds we've looked at so far, you see normal straight chain, then sometimes I'll say, trying to name this compound, identify is there any branch. So all these things, they are under aliphatic hydrocarbon. And we also have circular form. Circular form. The difference between circular and straight chain hydrocarbons or alkenes or alkynes is that the circular ones, we have two hydrogens lesser than the straight or branched one. Look at here. We have 3 carbon here. Every other thing hydrogen. So this is basically an alkane in circular form with 3 carbons. If it were normal straight chain, we would call this propane. But this is in circular form. We simply say cyclopropane. Now this has 1, 2, 3, 4, 5, 6 carbons. For normal alkane, it is C3H8. But the cyclic one, we have 2 hydrogen lesser than the straight of the normal one. So cyclopropane. If you add any branch, it will be the normal naming. You start counting from the branch or from wherever, you give your own naming. Just add cyclo to the parent. That is it for cyclic form. Then here is 1, 2, 3, 4, 5, 6. 6 carbon. That is a Z. Every other thing, double bond. So this is cyclohexane. If it has, let's say, one double bond somewhere or whatever, just name it normally. Just add cyclo to the root name. That is the difference in naming. So, under hydrocarbons, I said we have aliphatic, which are straight, branch, and circular compounds. We also have aromatic. Hydrocarbons are divided into aliphatic, and aromatic. The aromatic hydrocarbons are the ones that contain the benzene ring. Benzene and its derivatives are the aromatic hydrocarbons. This is, look at this compound. You have 6 carbon, C6. You see here double bond, single bond, double bond, single bond, double bond, single bond. So we call this alternating double bond. When you have 6 carbon with alternating double bond, that is benzene ring, and it is aromatic hydrocarbon. So aromatic hydrocarbon is basically benzene and their derivative. They have this very sweet smell. That is why they are aromatic. They will also have 6 hydrogen, because 1 hydrogen here, 1 here, 1 here, 1 here, 1 here, 1 here. With this, it is complete. Every carbon have maximum of 4 bonds. Benzene is C6H6. Now, if you look at here, for this benzene, it started with double bond, single bond, double bond, single bond, double bond, single. For the second one, it started with single, double, single, double, single, double. This is also C6H6. What this and this are showing is that the double and single bond can be at any point, at any time. It can be here now, it can be here. Single bond can start, double bond can start. So that shows that benzene has a resonance form. To show that the single or double bond can be anywhere at any point, we have a resonance structure of benzene proposed by August Kekule, which is like this. Like this. This is the resonance hybrid or resonance form of benzene. Now, to show benzene, instead of drawing all this, you can simply write something like this. Like this. To show single, double bond, single bond, double bond, single bond. All the other corners represent carbon. So, for simplicity, we'll take this as our benzene. When any element is added to the benzene ring, then it will have a special name. That's what we shall look at in the next episode, like how to name the various derivatives of benzene. Ladies and gentlemen, I trust you learned at least one thing from this episode. If you actually do, trust me, I'll be very, very happy. Now, get your Flashlearners Jamb app and begin to prepare for questions. Subscribe to this channel. Tell your friends about the Flashlearners YouTube channel. And if you have inquiries, questions, complaints, improvements, either you use the comment box or you chat me up directly. I am more than open to help you. I wish you success and see you in the next episode.